Hello students, welcome back. The final topic from section 4 is the proof. The proof of this formula here. In this example here, in both of those examples, I just put everything into this formula here and calculated yp. And then if you just add yp to c1, y1, c2, y2, then you're going to get the general solution. You see, this is a general solution of the homogeneous equation, and this much is yp. So once you prove this, then you're through. But then again, this one comes from here. u1 prime is this, u2 prime is that. So if you take the antiderivatives, you're going to get this integral and that integral. So if you prove this, then you're through. So that's where we're up to. Okay, ready? Let's prove it. First, we're going to start with this setup. Yp is u1 y1 plus u2 y2. And then don't forget the additional condition here, which I call variation of parameter condition, VP condition. You see, from here, if you take the derivatives and put it into original equation here, you're going to get one equation. One equation, two unknowns, u1 and u2. So we need additional equation. This green equation is the second equation. Okay, ready? Alright, this is a setup. Yp is u1 y1 plus u2 y2. And here's the VP condition. Take the derivative here. Product rule here and product rule there. So we have product rule plus another product rule. Do you see the derivatives? Okay, and then let's look at the highlighted part. This green plus that green add up to 0 by this green condition, VP condition, variation of parameter condition. So you end up with this expression. Let's go back. Yp is u1 y1 plus u2 y2, and then this is an additional condition. Take the derivative, product rule here and product rule there. So we have product rule here and product rule there. But then again, look at the green condition. This green plus that green add up to 0, so we have the rest. And then we take the second derivative, product rule, and then another product rule. Okay, we have all those derivatives, so put everything back into the original equation. Let's go ahead and do that. So, second derivative here, first derivative here, and the original. And then I'm using blue for y1 and brown for y2. And then please pay attention to y1 double prime, y1 prime, and y1. And they all have the same coefficient, u1, u1, u1. So factor it out, I'm going to get this blue. But then again, what is this blue? y1 double prime plus b, y1 prime plus c, y1. Here, b and c are actually variable coefficients, but that's okay. It's L of y1. Just plug in y1 here, y1 prime, y1 prime, y1, so L of y1, and that should be 0 because this is a solution of a homogeneous equation. Same for brown, y2, y2 prime, y2 double prime, they all share the same coefficient, u2, so factor u2 out, and what's left is the linear operator for y2, so that's 0 because this is a solution of the homogeneous equation, so that's 0. What's left is only this part. So in the end, this part is equal to f. There you go. We have an equation number 2. Equation number 1 is this one here, the VP condition, and this is the second equation. Now from this equation green and that equation red, can you find out u1 prime and u2 prime using the elimination method? It's just a system of linear equations, so you can easily solve it. And then, yes. So for u1 prime and u2 prime, take the elimination and subtract one from the other, then you get this. Again, the same deal. Take the elimination, and so for u2 prime, that's what we get. And the denominator is Wronskian. And then if you take the antiderivative, then this integral and that integral. You see? This line is coming from the system of linear equations here. Red equation and green equation. Nothing fancy. A lot of symbols, but nothing more than just system of linear equations. And then take the antiderivatives, and we have these two integrals. Alright, what is my yp? It's u1 y1 plus u2 y2. And here's my u1, here's my u2. So put everything into the original here. Yp is u1 y1 plus u2 y2. So y1 times this integral, y2 times that integral, that's it. That's my yp, the particular solution. And then if I add this yp to the general solution of the homogeneous equation, c1 y1 plus c2 y2, then you're going to get the general solution of the non-homogeneous equation. So we proved everything, and this is a practical formula to use. And then how do we actually utilize these formulas? We actually went through these two example problems. Tedious computations, yes, but nothing super hard. Elementary, just tedious. Okay, that completes everything here in this chapter.